We are busy with probability and tree diagrams. The exercise number 6 on page 361. A, you had to go and try for me. First one that you're trying. It says, 75% of the seeds of a certain type of plant yield white flowers, in other words, they make white flowers, and 25% is pink. So when you put the seed in the ground, it can either come out white or pink. 2 seeds are sown, and both of them germinate and grow. Use a tree diagram to determine the probability that both will be white, they will yield flowers of the same color, they will have flowers of a different color, whatever. But if I want the tree diagram, I have to realize how many circumstances are here. What is the 2? The first seed and the second seed will either give white or pink. So the first one can either then be white or pink. If the first one was white, the next one could either also be white or pink. If the first one was pink, the next one will be white or pink. Because this can be the crucial thing that lets your wheels come off. There were 2 seeds that were planted, and they want to know whether they're both white, both pink, different colors, whatever. So this was the whole thing you had to go think about. Now it's not half-half. They told you for whatever reasons why they got those data, that the chances of it being white is 75%, so this means 25%, and they did say that. If they didn't say that, it was logical. If the one is 75%, the other one's got to be 25%, because this has to make up 100%. Or if I put it in fraction form, this would be 3/4, and this would be 1/4, which adds up to 1. Whether it's in fraction form or in decimal forms, it gets to 1, and when it's in percentages, it must add up to 100%. So for the second seed, nothing changed. It's still 75% and 25%. And 75% and 25%. And if you stop there, you're going to miss some marks. What do you still need to do? Huh? So the outcomes can be, and now remember, it's white, there next to that one. And white, pink, there next to that one. You don't write them all here. So over here, pink, white, next to that white. And this would be pink and pink, and those are the outcomes. Now, some people also want to put the probabilities there. That's not what the outcomes are about. So for that, how many marks do you think? Could be more, could be less, but around about 3. For a tree diagram, it's around about 3 because it's an essence. Remember what I taught you? Start in the middle of the page so that when you branch out, you don't get cooked in here in one corner of the page. So now that wasn't even asked in this question. They just said, oh no, they did say. If they just said find the probability, whatever, and you didn't want to use the tree diagram and could do it without, no problem. But they did say use a tree diagram, so that you definitely be worth marks. Are there other options, methods that you can go and use? Definitely. Alright, so the questions were, what is the probability that both of them will be white? So what do I write here? Do you agree with me? So that would be that one. So what would you do with that branches? You must multiply them. Now if you write it this way, but remember now, I wrote it there myself, but I could have written it like this, white and white. So if it's white and white, the and will always be times. And all will always be plus. Wait. In Venn diagrams, all was, you add all the stuff together. Are you with me here? You've got to know what to do in which circumstances. If it's over here, and will always be multiplication. If we are inside of a Venn diagram, the and piece is where they intersect. Are you with me? Know what you're doing where. So this would mean that it's probability of white times the probability of white. That's too much writing. I don't need to do that, but I want to do the complete maths here. So what is the probability that a flower will be white? Did you use the tree diagram? Not really. You could have just used your brain here and said 75%. But please, you're not going to write 75%. and say 75 times 75 is I don't know how much. It's going to be percentages. So whether you write it into decimals or write 75 over 100 or write 75%, meaning when you put it in your calculator, that's what you're going to do, 75 over 100, that's fine. Just don't say 75 times 75 is a lot of percentages. Are you with me? And then that would give me how much? 0, 5? Okay, because we always round off to 2 decimals if it's rounded off correctly, am I right? Okay, did I even need the tree diagram? No, but the sum said I had to have a tree diagram, so you don't have a choice, you have to have the tree diagram. But basically you're taking the branches and you're multiplying them with each other. Second question said, with this tree diagram, what is the probability that they will yield flowers of the same color? So that means same color, both the same. If I had to write that now nicely mathematically, that would mean the probability of having white and white, pink and white, what the colors must come in between? Are you with me? White and white, or pink and pink. Now this is not going to be worth a mark, but if you write it like that, it makes sense to you that if I say and is times or is, and is times, it just makes sense. Now I'm actually shorting a step there to say probability of white, probability of white, probability of pink, which looks funny because it's PP, are you with me? And then to say what's the probabilities, or you could have immediately gone and said, well, the probability of white was 75%, probability of pink was 25 and 25. And again, I didn't really need that tree diagram if I knew what I was doing. So then, if you gave me the answer of 0.56 there, plus this answer is 0.6, which gives me 1B.
No, 0.006.
How did I know it can't be? Because if I add 0.5 and 0.6, it's over 1. Can't be. Probability can't be more than 100%. Okay, and the answer then, please? 62. Okay, so that one you could have rounded off, but better thing would be to put it all into your calculator one shot and give me the answer. Don't round off. Last question, what's the probability that they will yield flowers of a different color? So, 2 different colors would mean what? Probability of? White and white. Why am I so finicky about it? Because then your ands will be times and your ors will be plus. So white and white? Is that right? No, it must be white and pink. Or pink and white. But isn't that the same thing? It is going to be, but you can't just write once. Because this is the whole scenario. So where's the favorable outcomes for having 2 different ones? Would be white, pink, pink, white. There's not just one version, 2 of them, and that doubles my probability. So when I put it in here again, I'm skipping that step, saying BW times BW. Are you with me? So this will be the probability of white and pink. Let's just go for the tree diagram. White and pink will be 75% times 25%. 75 times 25, or write it with percentages, just do it correctly on your calculator, plus the pink and white, pink, white, 25%, 75%. And you knew it was going to be the same. So it's basically double whatever the one answer is. And then you can just give me the complete answer. If you want to first write that, and then give the answer, it's fine, but the next step would be worth 1 mark. Namely, 38 for the complete answer. So 38% chance that if I planted 2 seeds, they will both have different colors. 38%. That's what probability is all about. tree diagrams with a scenario like the following. If you have something like a bag of sweeties or a bag with balls in them or with, okay, I'll go into the details for now. If it is a bag full of balls, there are 6 red ones and 4 blue ones. And I say, put your hand in the bag and draw one, like the lotto. Draw one, and what's the probability that it will be red? 6 out of 10. Are you with me? Because that's the total number. So then probability is the number of favorable outcomes, the red ones is 6, over the total number that's in there, total is 10. So that would be the probability for 6 out of 10. But now I say, take 2 balls out. Take the one out, and then you put it back, and then take another one out. What would be the probability? So let's look at it. So this would be my first draw, whatever you'd like to call it. There's no correct English there. The first one that I draw out can either be red or blue. Are you with me? The redness is going to be 6 out of 10 and 4 out of 10 for the blue ones. Please don't simplify so that you can see them adding up to 1. Then the second ball that I draw can still be red or blue, and it will still be 6 out of 10 and 4 out of 10. Agree?
Yes, ma'am.
Because I took it out and I saw it was red, put it back. Saw it was blue, put it back. So now for the second draw, it will still be red and blue, still 6 red and 4 blue. So in all these cases, adds up to 1, adds up to 1, adds up to 1, and my outcomes are red, 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 blue, blue, red, blue, blue, and you've got 3 marks. The question is, what is the probability that I will have 2 of the same color? So which ones would that be?
Red, red, and blue.
That one and that one. So all you need to write is not even any formula. You could have just said, the answer is red, red. You're going to take 6 out of 10 times 6 out of 10. And add that to the other probability, would it be 4 out of 10 times?
4 out of 10.
If you write that in a matric final exam, you are perfectly 100% correct. I like to write it, but you say it's a probability of having red and red or blue and blue, because then I'm emphasizing the and part, the or part. So for the and part and the or part, that would mean this is what I'm going to do. Are you with me now? Yes. Give me an answer, please help me. How much?
0.5.
I agree. Now, different scenario is, if I say there are still 6 red and 4 blue, but I'm not replacing it. So I'm saying, okay, come by, take one out, put it over there. But then you can take your hand back into the bag again and take another one. Now there's going to be a difference to that scenario. This is with putting it back. This is now without replacing or without putting it back. Hopefully it's not sweeties that you took a bite and put it back. Okay? So you took the ball out, saw it was red or blue, put it back in. Same thing. So now what will happen to the tree diagram in that case? So we are going to have still red and blue. It's still 6 over 10 and 4 over 10. No problem. But now the scenario is, if the first one was red, then what is the possibilities for red and blue now?
Isn't it 500?
It's now going to be 5 of them that's left, and still 4 of them that's left, and there's only 9 balls, because I took one out. So now this is 5 over 9 and over 9, and still they add up to 1. Do you see happening?
Yes, ma'am.
This is the scenario, because I don't know if it's going to be a red one first or a blue one first, but the scenario is, if red, then. If blue, then then if it's a blue one, there will be only 3 ones left. But the red ones will still be 6. It's not that 5 that I've already done. That's a different scenario when it was red and I took another red. This is blue. Now I'm going to take out red. So there's still 6 possibilities. And now there's only 3 possible blue ones out of still
9.
very important, the 9. And could I do this again and again and again and draw a third and a fourth ball? Okay? We're not going to do that in a test because if I can test you on 1 draw, 2 draws without replacing, I've tested. Outcomes here are still red, 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 blue. Oopsie. Blue, red, and blue. Blue. And now this was the question. What's the difference? What's the difference when I want 2 of the same color by putting it back? And now I still want 2 of the same color, but this time I didn't put it back. So now, again with the writing it as red and red, or blue and blue, it's showing me the stuff, or I can just say. So if it was red, red, it would be 6 over 10 times 5 over 9, plus, remember now the trees, times, and the other one is the blue one, plus 4 over 10 times 3 over, and that's it. That's how the tree diagrams work. If you could do this without the tree diagram, because you can, it's a little bit tricky because you've got to remember that the next one is only going to be 9 and not 10 because you didn't replace it. Are you with me? Can be tricky, but if you got it, you got it. So, answer please.
0.47.
So, are the chances more or less than putting it back? Less, because you've already taken something out. So that makes your probabilities for what's left a little less. Are you with me?
Yes.
Okay. So your homework sum is D and G on page 361.